Hello, Assalamu alaikum everyone. My name is Uzair and I'm part of FAANA. FAANA is Fast Alumni Association of North America. And we started this webinar series almost 2 years ago now. Today is 19th session in this series. And we're gonna talk about careers in computer graphics. Our today's speaker is Novera Masood. She is a graduate of FAST Islamabad. She graduated in 2004. And since then, she has been working in various R&D capacity roles and software engineering roles. Interestingly, she has worked on numerous Hollywood movies as well as a computer graphic engineer. And her specialties lie in computer graphics and computer vision. And she is also the vice president of Pakistani Women in Computing, which is commonly known as PWIC. Today's session is pretty special for me as well, because like I said, we started the series a couple of years ago. And since then, I've been trying to get a woman Fastian on board. So this is the first time that we're having a woman speaker. So I'm pretty excited about it and, listening to what Novera has, to share with all of us. So thank you so much for taking out time from your busy schedules. I really appreciate it. And, especially 9 a.m. on a Sunday morning. So I know it can be hard. So, but again, thank you for that. And yeah, with that, over to you, Novera. Thank you.
All right, thank you for the introduction, Azar, and thank you so much for having me here. It's an honor to present this back to, the alumni that I'm so proud to be a part of. Okay, so hi everybody, I'm Novera. Today I'm going to be talking about careers in computer graphics. And just before I get started, I did want to talk a little bit about what computer graphics is. So computer graphics is basically generating and manipulating images with the help of computers, right? It really is the intersection of art and engineering. This is where it all comes together. And there are multiple fields in this field, right? So computer graphics means different things to an artist as compared to a software engineer. So, one half of this field focuses on engineering math problems, and the other half is completely art-based, right? It's for the artists, it's your graphic designers. In my talk today, I'm only going to be covering the engineering side. I don't have resources for graphic design or for artists. So I just wanted to give that disclaimer out there that because my background is in software engineering, the focus of this talk is mostly around the engineering roles that exist within this field. So with that, I'll go over the agenda. So I'm going to start with my academic journey as well as my career journey so far. And then I'm going to talk a little bit about applications of computer graphics, like what are the different industries that use computer graphics. If you do graduate with a graphics degree, where can you get a job, right? There's some obvious ones that you all probably do know of, but there are also lots of other industries where graphics is being applied that sometimes people are not aware of. So there's a lot of jobs that exist within those industries. And then I'm going to dive a little bit deeper into job roles. So what are the specific types of jobs? What are the titles that exist? What do they mean? And what is the work required for those job roles? And then in the end, I have some, 1 or 2 slides around how to get started in the field. What are some of the fundamentals that you need to know and some advice. And we will have a Q&A at the end. If you have questions along the way, please feel free to type them in the chat and then, Uzair can collect them. But I do think we'll have about 15-20 minutes in the end for Q&A as well. So please do, as questions come to you, please type them in the chat. All right, so getting started. Academic journey. So it all started with FAST. I did my undergraduate at FAST Islamabad, batch 2000. I graduated in 2004. I took computer graphics as a course in my final year, and my final year project was focused on computer vision and computer graphics. So basically that's kind of where it all started for me. I became very interested in the power of computer graphics. And, it was around that time that the first ever CG movies, full CG movies like Toy Story and Shrek had come out. And I really wanted to work on software that could make that possible. So, so that just like kickstarted my interest in this field. So at that time when I graduated, it was about 16 years ago, there wasn't a lot of gaming companies in Pakistan. There wasn't a lot of VFX work happening inside of Pakistan. And so I knew that if I had to get a job in the field like that, I would have to move to the US. The scene is much more different now. There's a lot more companies in the field. I'm in touch with a lot of founders. A lot of them are from FAST as well. So it is a lot different now. But back then, my only way of getting in the field was, okay, let's apply abroad. Let's apply for a master's degree, which brought me to the University of Minnesota. And here I did a master's focused on computer graphics and computer vision. And so this is where I got recruited. So, at universities, you have career fairs every year. So in my final year of my master's, I got recruited by Microsoft to go and work on a software called Microsoft Dynamics. Now, so for those of you who don't know, Dynamics is an enterprise software. There's no computer graphics work in this, but I was working at a Fortune 500 company. My parents were super proud of me. They were going to apply for my green card. So, everything was like subsetted, as they say, right? But there was no graphics work. So I really, really started to miss working on, graphics problems. I kept thinking, this is not why I left Pakistan. This is not why I left my family. This is not why I came here to work on a financial software. And so, I started looking around. I did stay in this role for about 1.5 years. But by then I was like, it's not worth it. If you're spending 40 hours of your week working on something that you don't enjoy, it's really not worth it. So I started looking around and landed a job at Disney as a production engineer for a studio called Image Movers Digital. So this studio worked on full CG movies that were based on motion capture. So motion capture is where there's a live actor and they perform a scene or they do a performance in a stage, and there's special cameras all around, and we put markers on these actors, and then we take that performance and then transfer it onto a virtual character. So the hope is that the animated characters look more realistic because they're being driven by a real human and real human emotions. So this was, the perfect job for me, because this was where I could use computer vision as well, because there's all these cameras looking at, actors, and there's the graphics aspect too, where you're animating a character. And so, I was super happy to have landed on this role. I worked on 2 movies at the studio, Christmas Carol and Mars Needs Mom. And then I moved on to another similar role at a studio called Digital Domain. So compared to the previous studio, which was full CG, this was more visual effects and live action. So live action is a mix of real actors as well as, special effects that you add on top of it. So here I got to work on a wide variety of tools. I was here for 4 years. I worked on a crowd simulation system for Thor. I worked on some lighting tools for Tron, a feather and hair system that got used in Maleficent. And then eventually I started getting back into motion capture as well. That was also used on Jack the Giant Slayer and Maleficent as well. And the facial system that we developed here at Digital Domain also ended up winning an Academy Award in 2017. So this was a very rewarding time in my career. I learned a lot. I learned about the whole pipeline. I got to work on different aspects of it. And then eventually, the last 2 years in this role, I was doing R&D development back using computer vision and graphics. So then, after working in the VFX industry for a while, that was my dream. I had achieved it. I was like, okay, what's next, right? So what do I do after this? I'm here. I'm still early in my career. So at that time, I was like, okay, it's time for a new dream. So, watching beautiful imagery on screens is one thing, but then being a part of it, like if you wanted to be fully immersed in it, that started to become, something that I wanted to be a part of. And it was around that time that the VR revolution was happening. Oculus had just come out with their headset. And, in order to experience these CG images, you didn't just have to be limited to a 2D screen. You could put on a headset and you could go inside and you could walk around the 3D scene. So that's what led me to my next role at Microsoft, working on the world's first mixed reality headset called the HoloLens. And so this is where, it's an augmented reality where you have virtual objects that are mixed in with your real world. And so here I had the opportunity to work on an amazing project called OnSite. It was a collaboration with NASA. It enabled scientists to do science on Mars. So we took imagery from satellites that are around Mars, and we would recreate the Martian terrain. And then geologists would put on this headset and get to see the Martian terrain in 3D. Like they could look at rocks like they would on Earth, and and then they could do their analysis. And before this, they were just doing it on a 2D, just looking at pictures basically. This software then went on to win 2017 Best AR Experience from Unity, and then in 2018 it won NASA Software of the Year award as well. So this was one of the highlights of my career. Then I moved on to another initiative within Microsoft called 3D for Everyone, where again, now I'm back to computer vision. So this was a scanning application. So there's a lot of scanning apps that exist that use depth cameras, and we wanted to use RGB only. So only using pictures can we reconstruct an object so that you have a 3D representation of an object. So I started working on that and really enjoyed that as well. All right, so that was my career journey in computer graphics. Now I'm going to talk a little bit about graphics applications, right? What are the different industries that exist that you could work in if you did have a graphics degree? So first and foremost, everybody knows about this, film and TV. So there's full CG movies like you see on the left here, Burqa Avenger, for example. So everything in here is computer generated, the world, the characters, the lighting, the effects, all of it, that is a very big customer of computer graphics. So a lot of programmers end up working in film and VFX. Then on the right, there's two types of VFX. One is motion capture, like I mentioned, where you have virtual characters that are being driven by human performances. So you're doing performance capture and transferring that over. And then on the bottom, you see a mix, right? This is live action where you have a real person performing, and then you add in a virtual character or some special effects afterwards. So examples that I know in Pakistan, again, so back then there was not a lot, but right now there's Unicorn Black, the company that makes Burqa Avenger, there's ICE Studios, B19 Studios, there's a lot of VFX work that's happening for Pakistani content, as well as I know that they're being contracted out for international content as well. The other obvious application is games, there's 2D games, games that you play on your phone. There's 3D games that are full immersive games, like more complex scenarios. Here you can see, a wide variety of applications where going from simple graphics and UI on the screen to fully creating, trees and rocks and animations and artificial intelligence. So all of that gets consumed in games as well. So film and games, probably the most obvious ones. Now I'm going to move on to a little bit less obvious applications, but we see computer graphics all around. The first one, social media, right? We've all done this. On the left, you see Instagram filters or even photo editing on your phone. Essentially what you're doing is you're taking an image and multiplying every pixel with a matrix. That's what's happening when you apply a filter, right? So all of this happens because some software engineer wrote a code to enable this. On the right, you can see something that Snapchat came out with. It's called Body Lens, where they're taking your human motion and then transferring it on to this little character. Oops, this again. So this is kind of like cheap motion capture in your home with your phone, right? And it's happening on an app that everybody has. These are all applications that use graphics under the hood. Okay, next up, so retail. Retail is a big user of graphics as well. On the left, you can see an app, Sephora, so it's a makeup company here. They have an app where you can actually try on makeup at home. So just looking at your camera, you can see how things are going to look. So virtual try-ons are a very, very big field where graphics is making, you can try on clothes at home. You can see how things are going to look before you actually go to the store and buy them. And then on the right, we have, this is the Amazon app, but there's Wayfair, IKEA, there's a lot of furniture stores that let you preview furniture. So 3D objects that, 3D models of these furniture, you can look at them, how they're going to look inside your house before you, buy them online. And with COVID, again, this has become, very important because stores have been shut down. So people are doing more online shopping. So both of these have really taken off, especially in this COVID era. Architecture is another big one, right? So architectural visualizations. If a designer can actually show you in 3D how your house is going to look before you actually go and build it, or if you are doing some modifications, so doing high quality renders and being able to see the changes before you go and put in money and actually make those changes. Architectural visualizations use a lot of computer graphics. And then on the right, you see Matterport, which is a company that comes and scans 3D houses. So they take lots and lots of images of your house and then they reconstruct that house so that you can actually walk through it. So it's a virtual walkthrough And this is being used in an application here to sell, to sell real estate. So, and again, with COVID, it's very difficult to go and see a house in person. But using this application, you can actually just do a virtual walkthrough. So all of this is using graphics and computer vision to do the reconstruction. Another industry that we usually don't think of when we think of computer graphics is healthcare, right? So healthcare has a lot of imaging, right? So all the time, doctors, and technicians are looking at medical data in some sort of an image. So if there's a lot of research that's going into how do we present that data in a 3D fashion. So instead of just looking at a picture, if they could reconstruct in 3D, if students could learn, for example, muscle systems or blood flow systems in 3D, it would give them a better understanding of how things are actually working. So for training and medical purposes, this is super useful. And then on the right, you can see, if you were able to look, if you did a scan of an organ, and then if you're able to look at it in 3D, maybe it would enable you to make better diagnostics. So, and again, biomedical imaging is its own field. You can do a degree in it, you can do a specialization in it. There's a lot of courses that you can take that just specialize on how do you take PET data or MRI data, and how you can construct that into a meaningful image for these non-technical people, right? So yeah, so that's a big field as well. Another one is manufacturing, right? So before you go and build, big models of anything, I just have a few examples here. Like if you're building a car, you usually do design it in a 3D software, usually something like CAD or AutoCAD. So what they're doing here is they're previewing what this car is going to look like before they go and build it. If there's changes that need to happen, it's a lot cheaper to make a change here than on a car that's already been built. And so what I'm showing here is just the 3D model. There's softwares that let you even simulate paint. So there's a lot of rendering work that goes into that, where how is this paint going to refract in certain lighting conditions? If it's a cloudy day, how will this paint look? So there's a lot of software that just focus on that as well. So manufacturing does have a lot of computer graphics applications in it as well. So there's the big objects, but then, on the right, I have like even nuts and bolts, like these get visualized before somebody goes and actually prints them out or builds them. They actually see how this is going to fit, and all the designing work is happening in a 3D software. Okay. And then next up, probably one of my favorite, space exploration. So, on the right, we see a space, like a flight simulator. So this is used a lot for practice as well as training. Astronauts, before they go into space, they do a lot of hands-on practice using these simulators. And this is an older picture. It's a lot more advanced now, where you do feel like you're, in space, or and you're simulating everything. So you're trained up before you go in practice. And then on the right is the software that I worked on site, which is, for Mars exploration, where geologists are using computer graphics to basically examine rocks and terrain in 3D. So this is just like a very brief overview. There's a lot of other fields, but these are the few fields that I thought would be worth calling out. Now I'm going to go into a little bit of detail on job roles. So within these fields, what are the specific job titles that exist? What do they mean? What do people do when they say they're doing, title X? So I'm going to cover those briefly as well. Okay, so firstly, it's user experience, right? So user experience is the user's journey through your application, through your game, through your mobile phone app, right? What is the person going to do when they start up an application? How do they get to the information that they're trying to get to, or how do they achieve the goal that you are trying to get them to do? So there's a lot of designers that are involved in this, but there's a lot of UX programmers that work on making that design a reality, right? So they're the ones that are programming interactive elements. They're the ones that are figuring out, here's where the button goes, here's where it needs to be laid out, this is the color. So all of this happens, it's a mix of design and programming. And so this is an important part, because this is how all the functionality that you built gets presented to your final user. So, user experience roles involve that. Then come image processing. So this happens in 2D. So, anytime you take a computer graphics course, the first thing you're going to learn is how to manipulate images, right? After images are acquired or generated, they usually are processed. before they can get used in other applications. So basically, one of the roles here is like pattern recognition. So this is where you analyze images, you recognize and extract features from it. So for example, when you upload a photo to Facebook, it knows that this area is a face, and it even goes beyond that. It suggests, this could be Novera or this could be Uzair, right? It's doing some sort of recognition, pattern recognition on those pixels, and saying, I think this is this person. So all of that is, image analysis and pattern recognition. This is also something that's, widely used in computer vision, for example, because this is the first step where you take an image, and if you have, even in robotics, if you're trying to understand the world around you and you have camera feeds coming in, you can take an image, you can do some analysis and try to do some sort of scene understanding from that. Okay, then all of this data, that is coming in, sometimes it's blurry, sometimes there's obstacles that came in the way. There's a lot of manipulations that happen. There's cleanup that happens, but then also there's enhancements that you can do. And this is, tying back to some of the filters work that I showed. If you want to edit an image, how is that going to happen? So image manipulations, there's a lot of algorithms that exist for that. So there's a lot of people who work on, generating new effects as well that you could do on images. Then comes data visualization. So now that you have these images, how are you using it to construct something meaningful for the user? And this all depends on the user that you are targeting. For the geologist, for example, the input data was images, but then we also had depth data coming in from satellites. There's information coming in from the rover itself on certain chemical properties of these rocks. So how do you collate all of that data and present it to your geologist? For a medical professional, it's a completely different problem where you have different types of scans coming in, and how do those scans convert into pixels on your image, right? So there is a lot of work that happens there. So, data visualization is its own field, lots of jobs in there as well. And they're completely focused on how do we present data in a more meaningful way. And so a lot of graphics gets used there as well. And then lastly is like transmission and encoding. So once you have these images, once you have data, if you need to, if I need to WhatsApp an image to somebody, if I need to transfer something, via email, or just like we're doing right now, we are transmitting images to each other while we're on the Zoom call. There's encoding that happens. There's some encoding that we're familiar with, like JPEG, MPEG. There's people who work on encoding algorithms as well. They try to compress all of this data and then decompress on the other end as well, mainly for transmission. So there's a lot of roles that exist within the image processing field as well. And this is one of the fundamentals of computer graphics as well. Then we move on to more 3D specific roles. And one of the bigger ones is like engine programming, right? So an engine is usually a compilation of various functionalities that are then packaged up so that programmers can do higher level application programming, and they don't have to reinvent the wheel every time, right? So every studio, every company that is going to do a lot of graphic work usually does invest in a good engine. And depending on your use case, you could have all 4 elements, or you could just pick and choose based on what you're going to do. So firstly, there's a graphics and rendering engine. This is where a lot of the math happens, right? So this is where your geometry is being stored. This is where you're doing a lot of optimizations for different hardware. So if your application has to run on a phone, the memory is limited, the graphics card is not as strong as opposed to running it on a PC. Different game consoles have different optimization. So there's a lot of code that's written for optimizing for best speed, best memory management happens inside this graphics and rendering engine as well. Then we usually have a physics engine. This is, basically simulating the physical world. So if 2 objects collide, how is that going to happen? How will the forces react on these objects? If you have cloth simulation, for example, if somebody is wearing a flowy dress, how will that, if there's wind flowing, how will that work? How does gravity work? How do fluids work? If you have a big wave coming in, what does that look like, for example, in film? So you usually have a physics engine that's simulating physics. Then comes an animation engine. So if you're going to have characters in your application or your scene, you're going to need a character engine. This is basically where you set up a 3D version of your virtual creature, and then you can also add in some physical constraints there as well, like this joint should not be able to go beyond a certain angle, and these are all based on realistic body constraints as well. So an animation engine usually takes care of that for you. And there's people who are programming all of this. They're studying this and then they're translating that into code inside the animation engine. And then lastly, there's usually an AI engine, much more common in games, but also making its way into other fields as well. This is where, pathfinding is one of the biggest ones. If you want multiple characters to go from point A to point B, you're not going to program each and every one of them. You're just going to give them a high level command like cross the field, and they would automatically, based on the obstacles that are there, try to figure it out, right? So what is the best path without hitting anything on the way? So there's usually some sort of AI that's involved in that. Behavior modeling is another one. If you have crowds, how are they going to react? If you want to simulate like a war scene in a movie, how are you going to program them? You're not going to program every single character individually. You usually do some sort of like a crowd behavior system. And then most recently, machine learning, right? So this also comes under AI, but machine learning is now being applied to all of these fields. Like we're using machine learning to speed up rendering. We're using machine learning to simulate physics. We're using machine learning for animation. So that's coming in AI as well, but being applied to all different fields. So there's a lot of jobs right now. If you want to apply machine learning to graphics and 3D roles, there's that's a big, future looking career as well. Okay, and then lastly, I think is, I have one more, rendering. So if you wanted, so all the programming that I mentioned before this happens at the CPU level, but computer graphics is about manipulating images, and images are made up of multiple pixels, right? And sometimes if you want to do an operation, it has to operate on every single pixel in your image, which is very, very expensive to do. So what we do to optimize that is do that programming, do those effects and those calculations on the GPU. So the GPU is highly parallelizable. You can do multiple, math operations in parallel. So we do take advantage of that. There's a lot of people who work on GPU programming for graphics, usually shader writers. They're doing a lot of post-processing effects. So there's, this is a big field as well. It's highly specialized. But if you do get into this, there's, really good career prospects. And right now, this is becoming even more popular with limited hardware. So, even with mobile gaming and all these other devices that are coming out that don't have a lot of memory, they are, reverting to like doing a lot more on the GPU. So GPU programming is also a very big field, and it focuses mainly on the rendering, but now a lot of other calculations are now also being offloaded to GPU. So this is something worth exploring as well. And then lastly, there's libraries and toolings. So all of the stuff that I mentioned, right? So the engine and the it's all a little bit lower level. But then there are packages that package it all up and then present it to other people, right? So for example, Unity, OpenGL, like you have a software app, like a software development kit, you have an API, it's been abstracted away. So if I want to draw a sphere, I don't have to write the equation of a sphere and then draw a pixel. I can just say, draw sphere and then give it a radius, and then Unity takes care of that for me. So these APIs and SDKs basically package it all up. So there's a lot of roles that exist for software engineers who are doing that. They're the ones writing those APIs. So you're interfacing with the lower level engine functionality, and you're creating an abstraction layer. And how do you create those abstraction layer? That's an art in itself, right? So how do you figure out how to present information to programmers, right? Here, you're still at the programming layer. And then a little bit beyond that is complete software applications, right? So we all use Photoshop to do photo editing, again, Unity and AutoCAD, but those applications are built by software engineers, right? Those are graphics engineers who are writing that functionality, who are writing code for that functionality that then gets packaged up into a very easy to use application for somebody who's a non-programmer. So, these are lots of companies like Adobe, Autodesk, they're all working in this field where they're creating these applications for non-technical people as well as technical people. And then lastly is tool programming, which is also known as pipeline TDs in games and film. This is when you're working on internal pipelines. So here your customer is your internal software developers. And usually you're being the bridge between artists and code. So you're writing tools that maybe an artist or an internal developer will use. But sometimes there's code that's happening in C++, but your artist is in Maya, and you need to write like an intermediate way for that. So you're basically connecting things. You're creating a pipeline, or the artist has set up some sort of lighting system, and now it needs to go off to get rendered on a different machine. They're not going to know how to do that. So you are going to write internal tools that maybe take that and send it over some networking over to that. So internal tooling is a big, you'll see a lot of jobs in this role, and that's what it means. Basically, you're writing tools, and these are super useful. It can bring down a whole studio if these tools are not great. And so pipeline TDs and tools programming, that's kind of usually what it means, where you're creating internal tools. All right. Next up. Okay. So that was very high level, of all the different types of roles. There's a lot more that exist, but those are the most common ones that you will see when you go to apply. How do you get started in this field, right? So depending on where you're at, there's different ways to get started. So if you're still in college, or if you're trying to relearn a new skill, there's a lot of courses out there that do exist. So some courses that I personally recommend are, courses on 3D fundamentals. You have to know your 3D math. You have to know how transformations work. You have to know rotations and translations and all the matrices that are involved in that. So every object in a computer graphics scene is stored as a matrix. So your 3D and 3D math has to be really good. Another thing I recommend is learn about the rendering pipeline. Learn what it takes to get an object down to images or pixels on the screen. There is rendering pipeline is important. There's slightly different ones for different architectures, but this is something that you will get asked a lot in interview questions as well. So make sure you're familiar with all the stages in that pipeline. And then linear algebra. So, do take courses in linear algebra. At that, when you're taking them in college, you're like, when am I ever going to use this? Trust me, in computer graphics, half of your life is linear algebra. You're dealing with matrices, you're dealing with, transformations, inverses of matrices, singular value decomposition. All of that does get used in computer graphics. So please do have good fundamentals. And now with the, with the recent injection of machine learning, all the machine learning is also, based on some sort of linear algebra. So it would really help if your fundamentals were good. So I highly recommend, these three, if you do introductory courses in these, or do a good job of doing some projects in these spaces, then I think you'll be set for starting to apply for careers in graphics. Some packages that I recommend are like Unity, Unreal, and then more on the 3D side are Maya and Houdini. So these are, again, higher level, where they've done all the hard work for you. I do recommend make sure you know what's happening under the hood. So a lot of applicants, they will come in, they'll know how to do stuff in Unity, but they don't really understand what's happening, right? What is it actually doing? Like the draw sphere, that example that I mentioned, they know how to call that, but they don't really know what's happening under the hood. How is Unity actually doing that work? And sometimes we're looking for that as well. You have to understand what's happening under the hood, or and then these packages make it faster and easier for you to get started. Basically, you can use Unity to quickly create an app. Like over a weekend, you could probably follow a tutorial and make a mini game, right? So they've packaged up functionality really well. So it's a really good way to get started, but do try to go deeper as well. And then some languages, I'm mentioning the three most popular ones for lower level graphics. So if you're interested in shader writing, so OpenGL, Metal, DirectX, all of these, learn how to write shaders for them if you want to do more advanced shader programming. And then for shader programming, there's a website called shadertoy.com. I highly recommend that. People post their shaders on there and along with their code. So you can take a look at an effect, and then you can actually dive into their usually like GPU code, like how is it running? What is the equation that they're using? How did they get to a certain effect? And you can do a lot of like self-learning through ShaderToy as well. And then I just did a sweep, and these are the two courses that I thought covered a lot of fundamentals. So if you're already working or not in college and want to get back, or trying to switch your field, these courses on Udemy are highly recommended. They do cover a lot of the basics that you would do in a graphics course if you were studying in university. So we'll be posting these online as well. So please go. And I'm sure if you do a search, there's a lot of free courses that exist, but anything that covers fundamentals is important. Okay, so that was kind of it. I'm just going to end with some advice. So, this is general career advice, not just for computer graphics, but, if you are trying to grow in your field, basically the topmost advice is create a strong professional network, inside your company, in your industry, and also outside of your industry. So a good network can really increase your chances of growth. And also your knowledge base, right? We're all part of this network here. So FAANA is a network. I'm part of PWIC as well as Pakistani Women in Computing. So make sure you connect with people and take advantage of that, right? If somebody is working at a company that you want to work at, just reach out to them, ask them for a referral, or reach out to them and ask them for advice. People are generally very, very helpful. And we all got here because somebody helped us along the way. So do take advantage of this network that you're a part of as well as others. So, join networks, create networks, and take advantage of them. Secondly, have a career plan, and then, actively seek mentors that can help you achieve it. So if there's somebody working in a role that you wish you were at, reach out to them, ask them if they're able to mentor you, set up, time, maybe once every 2 months. Have a plan with them, create some sort of tangible goals that you're going to achieve. But having a good mentor can really, really accelerate your career growth, or help with your career transition if that's where you're at. But I highly recommend reaching out to people and asking them to be your mentors. Worst case, they'll say no, you can always ask somebody else. So it doesn't hurt to ask. And then lastly, take calculated risks. Don't be afraid of failing. We all failed along the way. We didn't get here because, everything was perfect all the time. We just learned to move past it, right? So failures are going to happen. They're a part of life. Just get up and try again, and keep trying. And then, if you have found something that you're passionate about, if there is a career that you really want, just take the risk and go for it, try it, right? So when you're doing something that you're passionate about, honestly, you're going to be so much more productive than if it's just a job. So I highly, highly encourage people to take risks, calculated risks, right? Don't be don't let everything go, but if it makes sense, take the risk, do your analysis, and then don't be afraid to fail, because those are just learning opportunities. And so that's all for my talk. Thank you everybody for attending, and thank you, FAANA, for inviting me to share my story. And I think we can move on to Q&A. I'm happy to answer any questions. If you have questions that come up later, please do reach out to me on LinkedIn. I'd be happy to answer them as well.
Sure. Thank you, Navera. Really appreciate it. I think there were some like really good points throughout the talk, and especially towards the end that you mentioned about the importance of networking and reaching out to people. I think a lot of time we feel like shy and just not comfortable, but like you said, the worst that can happen out of it is other person say no, so you can always move on to the next person. And the other thing that I really liked was the importance of linear algebra. So like you said, a lot of times when we are going through those equations and matrices and everything, so we feel that what's the practical use of it, but I think it was good of you to bring that up, that in computer graphics they are actually used. So thank you for that. I do have, when I sent out the registration form, we got some good questions. So I've shortlisted a few questions that I'm gonna ask you, and then we'll go through them quickly, and then I'll open the floor if anybody has any questions, and then we can go through it. So the first question that we received was, it's for you, since you have worked as a pipeline in pipeline TD, please tell us about the job scope and must-have skills for this role.
So pipeline TDs were the internal tooling that I mentioned, right? So these are people who it's a big field in gaming as well as visual effects. A lot of skills that they look for is exposure to different softwares. So as a pipeline TD, you're probably going to be writing code for Maya. You're probably going to be writing code for Houdini. If you can make yourself familiar with writing plugins for these softwares, that's going to increase your chances. A lot of pipeline programming is happening in Python these days. So if you can familiarize yourself with Python, that would also be a good starting point. But generally Python, some C++, and familiarity with packages like Maya, Houdini, Unity, these are usually helpful.
Okay. The next question that we received was an interesting one. So what made you get into computer graphics? I think you covered a little bit of that in the beginning of the presentation, but the other part is pretty critical. So the question is it okay for an aspiring computer science student to get into computer graphics or computer designing in his or her initial semester? If so, what would be the approach? So yeah, if you want to talk a little bit about that.
Right. So I think you can't get to computer graphics until you know fundamentals of programming, right? So this is an advanced field, right? Like networking, for example, you can't straight away start programming networks if you don't know the basics of computer programming. So I do recommend, if you're doing it's a specialization, basically. If you're doing a specialization, you need to have the fundamentals there. So I would not do a specialized course in your first 1 or 2 years. First 2 years should be focused on covering the basics, learn about everything. And then in your final 2 years, that's when I would recommend taking a specialized course, because then you narrow your options too early. And if that's not for you, then it's too late to change. So I do recommend, in your final 2 years or even your final year, that's when you take these specialization courses.
Okay. Yeah, like you said, in the first couple of years, just focus on your like math related courses, linear algebra and different.
Yeah.
So next question is, it's an interesting one as well. Is it important to go overseas for a good career in computer graphics? Is the industry really as demanding as it looks from the outside?
So I think it depends. I think, again, I left, 16 years ago, and the scene was very different back then. Right now, there's a lot more companies that are working in this field. There's animation studios. There's even in marketing, there's companies that are using graphics for marketing. There's game studios, mobile games, as well as now VR, AR games as well. So the industry has really taken off. When you compare it, it still might be less as compared to what you would get in America or in Europe. But there are opportunities that do exist in Pakistan as well. So you don't have to leave. It's not the same as it was, right? Basically, you do have options inside of Pakistan. So that's there. And then what was the second part?
The other part was, is the industry really as demanding as it looks from outside?
Yeah, it depends on which industry you mean, right? So there's multiple applications. If you are in film and game, it is very demanding because there is a release date tied to it, right? So when they announce that a movie is going to be released on March 30th, it has to be released on March 30th. So there is kind of like a death march that happens closer to the date. And then, but there are cycles, right? So after you've done that crunch, then you're usually more, and this is the same for game industry too. When you're about to release a game, couple of months leading up to that are going to be very, very demanding. You're going to be putting in late hours, but then the cycle resets, and then you have some downtime. Honestly, that it does take a toll, and that's one of the reasons I did want to leave that industry too. And in the software side, there is still pressure, but it's not as intense as it was in film and games. So it is quite demanding, but
so
it's also rewarding.
Yeah. So I know you mentioned that if the movie has to release on a particular date, and before that everybody is scrambling to meet that date. So like, do you guys have a T minus 15 days like cutoff date that you need to get everything done, or like what does it look like? Just to be curious.
Yeah, there usually are dates because you have to provide it to the, for example,
the distributor or something.
Yeah, exactly. You have to provide it to the distributor. It has to get, copies have to get made. There's different formats. For example, a movie is getting released in IMAX versus regular screen. There's a trailer that has to get made before that. So there are deadlines for all of these along the way. But usually you're like, before they start advertising and they go big, you're usually done with the movie. So okay. The work is done a lot before, but even that deadline is quite strict. Yeah.
All right. So the next question is, what, I know you covered it a little bit, but the question is, what do companies usually look for in a job applicant in this field? What can make a job applicant stand out from the rest? Right.
So I think, coming from experience, I interview a lot. I do hire for my team as well. Fundamentals, you have to know your basics. There's a lot of passion projects that people do, they'll just, they'll pick up Unity and they'll create a game. But then when you dig in a little bit deeper, same thing, the knowledge breaks down. They don't know what's happening under the hood. So I think that's really, really valuable. Make sure your fundamentals are there. And the three things that I mentioned, your 3D math, your linear algebra, your rendering basics. If you know those, and those are, it's just a refresher of your introduction to computer graphics course. All of that are in there. But if you know that, that's usually what you will get asked in interview questions. And then what makes you stand out is if you've done side projects, right? There's a lot of applicants who are making a game on a weekend, or they created shaders for Shadertoy, for example, or if there is something that you've done extra, if your job is not already in computer graphics. If you're already working in graphics, you already have a great portfolio. But if you're trying to make a switch, try to create that portfolio on your own. There's a lot of online resources that will make you stand out, because then we can ignore what you've been doing and take a look at, okay, this person was self-motivated, they took an action, they learned, and here's the results. So take time to do those extra projects if you're making a career switch.
Okay, I'm gonna ask you one more question, and in the meanwhile, if somebody from who has joined right now, if somebody has any question, please feel free to either raise your hand, or unmute yourself, or drop in the chat, whatever you feel comfortable doing, and we'll take your question after this last question that I asked. So the next question is actually from one of our participants right now, Hamad Rauf. He is thanking you for the talk, and he has two questions. So the first one is, does one need to be an expert artist in order to succeed in the computer graphics? And the second question is, if one is very good in art, then is computer graphics a career option for him, her?
So I think what you're referring is to the art side, right? There is a whole field in that I didn't cover. If you are interested in this, then it would definitely be useful to get some formal training, before you, there are a lot of careers. There's a lot of graphic designing careers. There's a lot of careers for artists in this field. But, you do have to have a very polished portfolio. And even those artists are usually not self-taught. They've gone through some formal training. There's a lot of art diplomas that you can do as well. And those are not like 4-year degrees. There's usually 1-year, 2-year programs that you can do just in animation or just in effects. So there are a lot of formal trainings. I highly recommend that. If you are interested in this field, take some sort of formal training, get a degree, get a diploma, create a portfolio. Basically, when you apply as an artist, everybody's looking, they're not looking at your resume, they're looking at your portfolio. What is the work that you've actually done? How complex was it? Did you use a mix of different techniques? And so you can only do that if you have learned those techniques. So I think there are a lot of opportunities, especially here in the US, and now even in Pakistan, honestly, they're struggling to find artists to do the work that they have. So I do think it's a good career option, but make sure you have some formal training before you get it.
Okay. I have one question from Numan Bhai. Let me unmute him and I'll have him ask the question directly. So,
Assalamu alaikum, Nuvera. So the question I wanted to understand was that how is the career trajectory? So you learned, your fundamentals are good, and you ended up working in this space. So in traditional application development, you kind of start developing, then you become an analyst designer, then you move to an architect or to a managerial role. So there is a well-defined track over 10, 12 years. What does that look like in this space?
It looks exactly the same. It's you do the same thing. You have two options. You can either go into an architect role. So, those architects are designing graphics engines, you're designing AI engines, you're designing maybe the physics engines. So you can either go into that role, or you can get into management where you're managing multiple products. How are different products going to work with each other? It's almost exactly the same. The place where it differs is maybe in the film industry. So when you're in film and maybe in games too, you have the titles are different, but the work is the same, right? So you get to be a supervisor where, you're an animation supervisor. You're figuring out how all the different animation pieces are going to fit together. And then you become like an art director. And that's, you can choose whether to go more art specific or pipeline specific. So it's similar, like the work is similar, the titles are a little bit different, but the same two tracks exist. You can be an individual contributor, you can get more and more technical, and that leads you to an architect type role, or you can start getting into people management, and that leads you to more general product ownership role. I hope that answers the question.
Okay, yes, thank you.
Okay. If anybody else has any question, we have a few more minutes, we can go over it. Meanwhile, I have another question. I know where you talked about, opportunities in Pakistan. Do you, by any chance, like on top of your head, know any companies or other like institutes or like projects happening over there that you find very exciting and you would, recommend or have people explore those things?
So I'm, my knowledge is a little bit outdated as well, but I have been in touch with a few people. So VR Play is a company that makes a lot of mobile apps.
Yeah.
Mohsin is the co-founder of that, and so he used to work at Trango. So Trango Interactive, I think is still quite active, and that's I did work a little bit with a company that was affiliated with them, Folk Particle, as well. So they were one of the first pioneers, and one of the CEO or the CTO of Trango Interactive was actually my graphics teacher as well at FAST. So that's one. There's Unicorn Black, which is doing animation, right? So they're doing the Burqa Avenger stuff. There's
it's actually interesting that I'm not sure if it's still true, but Unicorn Black was founded by Haroon, the singer.
He's still quite involved in this.
So they actually had a music blog as well when they first started, like in 2013, I believe. Like, so I actually wrote for them for a little bit.
Oh, nice.
Yeah, but I know they're doing like Burqa Avenger and other stuff as well. And and then
in Lahore, there's like Mindstorm Studios, so they do gaming as well. And honestly, like I think I just did a sweep, like gaming studios in Pakistan. There's like a list of so many people that are doing that.
So it's like there are opportunities over there as well. It's not like you have to have, come over here in US and, only then things can start. You can actually start over there as well.
Yeah. And then I'm hoping to find out more soon. That's an area that I would like to reconnect to find out more what's happening in Pakistan in this field as well.
Cool. Looks like we didn't get any other questions. So let me go over my list. Yeah, there is one more question about can you please give us a futuristic idea about how this technology is changing and how we would be directing our movies in future?
So in my opinion, the technology is getting more and more immersive, right? So people are creating more VR, AR experiences. They're putting people in these movies, right? There's interactive films that are coming out. I don't know if people have seen like it at Netflix. There's a lot of interactive shows where it gives you an option. So you can pick which storyline to do, right? So the engagement of the user is increasing. So instead of just being very passive and just looking at it at a flat screen, they want to get the user more involved even in the storyline. So I think interactive storytelling is going to be big pretty soon. And then especially when you're in the movie, when you're wearing a headset, if you're in VR, if you're walking around a movie, you can go wherever, right? So you're not basically being directed towards a particular scene. So how does that play out? So I think that's a very exciting new thing that's upcoming. There's studios that have just started working on it. They're just scratching the surface, but I think that's going to be big in the future. And in terms of technologies, I think, again, applying machine learning and more AI techniques. So, the graphics pipeline that I've mentioned has traditionally stayed the same for the last 20, 30 years, right? I think it's now time for a shakeup. So a lot of people are using machine learning to do a lot of these techniques that were done, using programming. And so they were more expensive because we had to do them that way. So applying machine learning to these novel areas, I think that's another, future facing thing that's happening right now. So I think both of these are exciting in that space.
All right. Thank you so much, for covering all those questions. And like Noera mentioned, if you have any more questions, you can feel free to reach out to her at LinkedIn. She already shared her LinkedIn address. And One more thing, since we are recording this session, I will be putting this online on our YouTube channel as well. So it would be up there for viewing for later as well. So with that being said, thank you, Novera, once again. I know it's always hard to take out time, so I really appreciate it. And over the last few days, all the time that you've spent in putting all these slides together. So thank you for that. And yeah, thank you everybody for joining in, and have a good rest of your day or evening wherever you are at. So thank you.
Thank you so much for inviting me. This was great. Thank you.
Thank you. Bye.